Today we're going to talk about how we classify matter. Matter can actually be classified into two broad categories, and then each one of those categories can be further subclassified into two more categories. So on the board behind me I have a branching diagram, and we'll go through that so I can help you understand what this classification system is. So remember, matter is anything that has mass and takes up space. We can measure the density of matter by taking the mass of that sample and dividing it by the volume and coming up with the density. But the types of matter that there are would either be a pure substance or a mixture. And when we classify these, what we're thinking about is the types of atoms that each one is made up of. So in a pure substance, I have only one kind of an element or a compound. So what do I mean by a compound? Well, first of all, let's talk about what we mean by an element. An element is simply just one kind of atom. So I might have a hydrogen atom, I might have an oxygen atom, I might have an iron atom, I might have an atom of aluminum. And so if I were going to represent that with some sort of a diagram, I might take my atom and say, well, maybe it looks like just a colored dot. Maybe I have another kind of atom, like maybe if this one's hydrogen and maybe this one is oxygen. And so I'm going to represent that one with an open circle. And so if I have just one kind of atom, then I'm going to have an element. Now sometimes I may have a couple of these same types of atoms that are hooked together. So maybe I have two hydrogen atoms hooked together, or maybe I have two oxygen atoms that are hooked to each other. But in a particular container, and if I'm going to put a dividing line right down here like that, this container is an element, and this container over here would be an element because there's only one kind of atom in that particular container. Okay? So my scheme there was trying to show you how I might represent different kinds of atoms, but to have an element, I'm only going to have one kind of atom in a particular container, in a particular sample of that matter. Now, a compound is where I have two different kinds of atoms, and they're actually bonded together or stuck together, glued together, you might think of. So, for example, if this was hydrogen and if this was oxygen, water is what I have if I have one oxygen and I have two hydrogens that are bonded together or stuck together to that. And so you can see here in this diagram of this water molecule, I have two different kinds of atoms, which are two different kinds of elements, and they will be bonded or they will be stuck together. If I had a carbon atom, and maybe I'm going to represent a carbon atom by doing that, I could put a carbon with one oxygen and make carbon monoxide, which is a deadly gas that if you breathe too much of it, it would kill you. On the other hand, if I take a carbon atom and I put two oxygens with it, I now have carbon dioxide, which is what we breathe out all the time. Okay, so an element means you just have just one kind of atom. A compound is if I have two different kinds of atoms and they are actually bonded together. Okay, so examples of elements, like I mentioned before, helium in a balloon. Aluminum, like aluminum foil. If you pull out a sheet of aluminum foil, that's just straight aluminum. There's nothing else there but aluminum atoms. Hydrogen, oxygen, nitrogen, those are all examples of elements. Compounds, two atoms bonded together. So if you have table salt, that is a sodium atom and a chlorine atom, compound there. If you have table sugar has got a whole bunch of carbons and hydrogens and oxygens all bonded together, all stuck together to make a molecule. So table sugar is an example of a compound. Okay, but those are classified as pure substances, and I only have one kind of element or one kind of compound present. Now, opposed to that, then, if it's not a pure substance, you're going to have a mixture, which is why I have a combination of two or more substances put together. And there are two different types of mixtures. I can either have a homogeneous mixture or I can have a heterogeneous mixture. And homogeneous is going to look the same all the way throughout the mixture. You've probably heard of homogenized milk. when they homogenize milk, what they do is they do something to it so that the cream doesn't separate from the rest of it. If you just take milk straight from the cow, the cream's all going to float to the top and you're going to have the milk on the bottom. When they homogenize it, they treat it in such a way and mix it in such a way so that they will not separate anymore, so that it's all mixed together. So homogenized milk looks the same throughout. The cup of tea that I've been drinking this morning, I take my tea bag and I pour my hot water over it, and once it's steeped for a while, I'll pull the tea bag out, and then I have a cup of tea. And that is a mixture because there's tea in there and there's water in there. If I would have dumped sugar or honey into my tea, then that would have been a mixture with water particles, tea particles, honey particles, or sugar particles, or whatever else I would happen to put in there. So that is a homogeneous mixture because it looks the same all the way through. Even if you do something as simple as maybe you're going to put a pot of water on the stove and you're going to make spaghetti. And so you have your pot of water and you put salt in there. And then you have salt water. So you've got salt, which is a compound, and you have water, which is a compound. They're both pure substances, but you've now mixed them together into a mixture that, salt water looks the same all the way through once that salt's dissolved, so it looks the same all the way through. Now, you can also have a heterogeneous mixture where it doesn't look the same all the way through. If I had a glass of iced tea and I had my tea and then I had ice cubes in it and then I threw a chunk of lemon in it, well, that doesn't look the same all the way through. The lemon's kind of floating there on the top, the ice cubes are floating in there, then there's tea in there. I can pull out those different pieces. It doesn't look the same all the way through. If you have a container of trail mix, you could easily separate the M&Ms from the peanuts, from the raisins, from the almonds. Okay, it doesn't look the same all the way through, and so it is heterogeneous. What you have to think about when you're trying to classify something as to whether it's a pure substance or as to whether it's a mixture is if you could reach your hand in and pull something out down at the molecular level, would you pull out the same thing every single time? Because students tend to get mixed up between pure substances and homogeneous mixtures. But again, you have to think about what's going on at the molecular level. So, as an example, if I have a salt shaker, everything I pull out of that salt shaker is salt. I can't reach in and possibly pull out anything else but salt out of my salt shaker, okay? On the other hand, if I have salt water and I have dissolved salt in there, or if I've dissolved sugar in my water, for maybe, I know I like to feed the hummingbirds in the spring of the year, and so I'll take sugar and I'll dissolve it in water and put it in my hummingbird feeder. And so if I was able to reach out and pull one molecule out at a time, I could pull out a molecule of water, or the next time I reach in, I might pull out a molecule of sugar. And maybe the next time another molecule of sugar, and the next time a molecule of water. So if you can get down at the molecular level and pull out two different things, then you're going to have a mixture. Okay, so a homogeneous mixture looks the same all the way through. And so, for example, if I had air, I might have a mixture that looked like this. I might have some hydrogen, and I might have some oxygen, and I might have some carbon dioxide floating around in the air. So this is a mixture. And so if this is air, the air looks the same all the way through, but if I would reach in and pull something out specifically, a specific molecule, I'm not going to pull out the same thing every single time I pull something out of it, okay? So homogeneous mixture would be like air. Again, it would be sugar water, would be an example here. Heterogeneous mixture does not have a uniform appearance, does not look the same all the way through. So this would be something like trail mix. It would be something like vinegar and oil dressing. Because if you're aware of vinegar and oil dressing, you have to shake it up because it always separates. The vinegar goes to the bottom and the oil goes to the top. And so you always have to shake that up like an Italian salad dressing. And so those are heterogeneous because they separate. They look different all the way through. There's different things floating in there, and so it does not look the same all the way through. Okay, so that's going to be how we classify matter. We're going to classify it down into pure substances, which is going to be either an element, one type of atom, or a compound, two types of atoms bonded together. Or I'm going to have a mixture, which is where I have two or more pure substances mixed together. Homogeneous mixture looks the same throughout. Heterogeneous mixture does not look the same throughout. And again, if you're trying to classify the difference between pure substance and mixture, think about if you could reach in and pull out a molecule at a time, would you get the same molecule every time? Because if you would not, then you're going to end up having a mixture.